All right, here we are, still in chapter 3, but now we're moving on to lesson 2. Lesson 2 specifically talks about slope. Now, in lesson 1, we talked about a constant rate of change, and we referred to it as such, but really, if it is a constant rate of change, we know it's a straight line. And guess what? That constant rate of change really is slope. All right, so with our vocabulary, we're going to add a couple over here in slide number 2. The term slope describes how steep a straight line is. Slope is a ratio of two numbers: the rise, which is the vertical change, over the run, the horizontal change. So you'll see I filled in a bunch of things here. I got rise over run, I've got change in y over change in x, then I have this little triangle y over x. That just, the triangle stands for change, so how much y changes over how much x changes. The hardest part you're going to find about slope is that the y, which is usually our second number, that is the one that goes on top, where x goes on the bottom. Okay, slope is a rate of change. All right, it can be positive or it can be negative. If it's positive, we always kind of think of going to the right, because everything in our life pretty much goes left to right. When we read, when we write, when we drive on the right side of the road. So if we imagine as we go to the right, if we go up, that is positive. If we go down, that is negative. Okay, and we're going to get to some other stuff too when maybe we're not going up or maybe we're not going down, and we'll talk about that after a while and maybe add to our little diagrams here. Okay, but for the first type of question, what we're going to do is just find slope. Maybe they have a picture, like in example 1, find the slope of the treadmill. Well, how much does it rise? What's the vertical change? It's going up 10, and the horizontal change is 48. So they put 10 over 48, and as always with fractions, we reduce. So we get 5 over 24. Down here on this example problem, try and cover it up so you guys can't see it right away. It's not, there's no picture, but if we read carefully, it says a hiking trail rises 6 feet for every horizontal change of 100 feet. What is the slope? Well, the rise is 6, and the horizontal change, the run, is 100. And when we're dealing with fractions, again, always reduce. So we can divide both of those numbers by 2, and we're going to get 3 over 50, and that is all we can do. It is reduced all the way down. All right, so we can find slope from a picture or from words, or if we turn your paper over, we can also find slope from a graph or from ordered pairs. So take a look in slide number 5, back at the first page. We've got a graph. So on the graph, any point on that line will work. So when I pick points on a line, I pick nice ones. Take a look at the ones they've already picked for us. 2, 4, and 3, 5. Now, if I've got a graph, I don't need to use that ordered pairs. I simply count. Well, it's going up 2 and to the right 1. So I put rise 2 over run 1, 2 over 1. And you can leave it 2 over 1 or you can reduce it to 2. Either way is fine. Okay, now we can also, if they don't give us a graph where we can count up or count down, then we can use the formula. On slide number 6, we see the actual slope formula. And honestly, you guys, that looks a little bit freaky and a little bit goofy. But what we have to pay attention to is the fact that they're referring to ordered pairs. They're referring to points or coordinates on a graph. So take a look. They call them x1, y1, x2, y2. That's a point and that's a point. So notice, you take the y minus the y. Now I know it says 2 minus 1 and 2 minus 1, but it doesn't really matter which one you start with. As long as whichever y you start with, you have to start with the same corresponding x. Okay? So any 2 points will give you, any 2 points from the same line will give you the same slope. Take a look down here. We do have some interesting things that happen though. What if our line doesn't go up and to the right, like this? What if it doesn't go up and to the right? It just goes straight sideways. Well, if we think about that, what's the rise? The rise would be 0. And then the run, who knows? It goes on forever. But if we have an ordered pair, this is what it's going to look like. It's going to be y minus y, so we get -2 minus -2. Notice even when it's a negative, I still subtract, so that ends up being plus over 5 minus 7. And I get 0 over -2. It doesn't really matter what the denominator is, because if I have 0 of anything, I have 0, a 0 slope. And if you think about it, if we're going flat, it doesn't go up, it doesn't go down. What's the only number that's neither positive nor negative? 0. It's a 0 slope. Take a look at this bottom part. What if our line goes straight up and down? Now this one kind of breaks all the rules. As we go left to right, does it go up or does it go down? Well, it doesn't even go left to right. All right, let's do the math here. Y minus y, so I've got 4 minus a -5, and I have 3 minus 3. So I get 9 over 0. Well, I'm pretty sure you probably have your calculator close. If you have it close, type into your calculator 9 divided by 0. I can do it for you in case you're missing yours. When I type in, see if you can see it, 9 divided by 0, it says divide by 0, error. It does not work. We cannot divide by 0. So again, it's breaking all the rules. So when it breaks all the rules, it is an undefined slope. You actually have to write the word undefined slope. All right? So let's move on and let's do all of these and keep practicing. So change in y over change in x. Take a look at slide number 7. We've got a table. It's not a graph, it's a table. All right, so Garrett has, it shows how many pages Garrett has left to read in a certain number of minutes. Okay, so at 1 minute he had 12 pages left to read. At 3 minutes he was down to 9 pages. At 5 minutes he's got 6 pages. At 7 minutes he's got 3 pages. Okay, so we have to find, just like our constant rate of change, that's our slope. Change in y, which over here looks like it's -3, -3, -3. So change in y is -3 over change in x. 1 to 3 is +2, +2, +2. So our change, our rate of change is -3 over 2. That is our slope if we were to graph that line. What that really means for this situation is that every 2 minutes that goes by, he's reading 3 pages, because it's going down 3 pages for every 2 minutes of reading. Pretty good reader if you ask me. All right, let's try over here. We got 2 more examples on slide number 8. In the first one, we're taking right off the graph. So if you can see it, they kind of have 2 points drawn for you. If you'll notice, I'm going to say right away, as it goes to the right, it goes up. So I know it's positive. Well, from this point to that point, how much is it going up? 1 space, 2 spaces, 3 spaces. So up 3, and to the right, 1, 2, 3, 4. 4 spaces. So up 3, to the right 4. Can we reduce? No, we can't. Our slope of that line is 3/4. Okay, change in y over change in x. If we're looking at a table, change in y goes on top, but notice the y is down here. -2 to -1 is actually a +1, a +1, and a +1. Now -6 to -2 is +4. -2 to +2 is +4, and 2 to 6 is +4. So change in y over change in x, I have a 1 over 4. And that is my slope. Okay, we have a second page here, a few more examples. All right, take a look at slide number 9. In slide number 9, they say, find the slope of a line that passes through those 2 points. Well, if you have a graph, you could count them. I start on the right point. It looks like I have to go down 1 and to the right 1, 2, 3, 4, 5. Okay, so we can do that. Or if you don't get a graph, like in D and E, you can use your slope formula. Remember, it doesn't matter which y you start with. They started with 3 and subtracted 2 and then went -4 minus 1, and that's what they got. But you would get it if you use the other way as well. Okay, so down here, let's use our slope formula. So in D, I'm just going to start with my first y. So 2 minus 3, and first x is 2 minus second x is 5. So I'm going to get a -1 over -3. Well, just like in multiplication and division, when we have a negative divided by a negative, the answer is going to be positive. So we get a positive 1/3. All right, second one. Watch the negatives. Now, that doesn't change the fact that you subtract. So start reading with the y's. -4 minus a -2. Look at that. I still subtract. And then the x is -7 minus a -3. But when we subtract negatives, we add the opposite. And I get -2 over -4. Well, it's going to become positive, and if we reduce, 1/2. Okay, now I'm just going to go through this guided practice, and you can go through it too, and I'm just going to give you the answers to see how you do, and then we will be done with this lesson. So just maybe pause it and do the problems, and then turn me back on and see how you did. All right, so rise is 3 over run is 15, and so it's 1/5. Now, doesn't really matter. It doesn't say whether we're going up or down, so really a positive 1/5 or a negative 1/5 is kind of indifferent in that particular situation. Okay, and number 2, here are the 2 points. I'm going to start at the right. I go up 1, 2, 3, 4. So up 4, to the right 3. So I'm going to leave it improper, 4 over 3. It does me more good to talk about an improper fraction because I'm going up 4 and over 3. It wouldn't do me any good to change it to 1 1/3 because that's a little more difficult to visualize, frankly. Okay, in the table, change in y, +2, +2, +2. Change in y is, or x is +1, +1, +1. So pretty simple. It's 2 over 1 or 2 in that one. The slope formula, y minus y, so -2 minus 4, -3 minus 5, I get -6 over -8, which is going to be positive 3 over 4. The second one, 5 minus a -3, and -6 minus a positive 3 gives me a positive 8 over a -9, which is -8/9. All right, how we doing? Do you feel pretty good about this? Maybe you want to run it again and listen one more time. Otherwise, you can get started on your worksheet. We're going to do 2 worksheets on this, so we're going to start with the 3-2 skills practice, and that one will be due tomorrow. Thank you. Have a good day.